back to another video from Koiro, and this time I will actually be doing this. And this is a replica board of the 1581 drive. This is made by a Canadian that's called Core i64 or something, and he has made an enhanced version of this board. And the differences are in two ways as I see it. There are made some component choices on the board, but you can have a dual room setup in this, and he has also used an unused part of the board to make space for a power regulator so that you can power this with a power supply that is not the 1541 tube or the 1581 original power supplies. That's really it. And I do think I have most of the stuff that needs to go into this. And I will be going through the boom to check. Boom is short for bill of materials, if you don't know. And I do think I got everything, but we will make a check as we go along. And hopefully this will be completed in two parts. So the first part now will be soldering in and building the board. I'm not sure if we come as far as doing any test in this video. We have to see how long time this takes. The boom for the 1581 enhanced as presented on PCB Way together with the enhanced board, and this enhanced board is of course the board that is modified as we stated before with different opportunities, different options for CPUs and different room chips and also different power supply options. And these are standard components up here, and these are the normal IAC serial port connector, and this is the normal power connector, and this is something that I have from before because this is the same that I have for spares for Commodore 64s and other stuff. Pin headers, just standard. One N4148 diodes, probably the most common diode of them all. Ferrite beads, I do have some of those. EMI filter, I don't know if I have the right value, but I don't think that these will stop anything from working. This is just to suppress noise. The resistors and resistor networks. The resistor networks can be built with discrete resistors, so I will be able to fix that. Device selector switch, dip switch 2 position I have, and if not, it's possible to just replace them with wire links. Power switch, and this is the same power switch that I have for my Commodore 64 replacement, so this will be just fine, I think. The 6502 CPU, and here they have all the options. This is the Western Design Center C version, this is the old C version, and this is the ordinary 6502. Yeah, that's used in the VIC-20 and so on, and the older drives from Commodore. And I have a bunch of these, and I do have some of these too, no problem. And the EEPROMs, I have both 256 and 512 EEPROMs, and they will be easily used both with my UV eraser and with my MiniPro programmer, so that will not be a problem. And you have the floppy controller chip, and here they also have two options. The VD1770 is the more common one, and I do have some of those laying around somewhere, and I don't think I have any 1772 chips, but maybe. And this one, the MUS 8520, that's a CIA chip, and this can actually be replaced by a normal 6526 chip because this is the CIA chips that came with the Amiga 500. And the only real difference between this and the 6526 is that the 6526 has the counters and timers in addition to all the other functions, and I think they are all the same as these, but just without the timers, because in a C64 it's actually possible to make the machines work with the 8520 chips. The only thing that doesn't work is anything that requires the clock or the timer circuits. The LS139 I have, and LS00 I have. 7406, that's the old one that we know from the Commodore 64, and this is the real power hungry version without the LS, and I do have a bunch of those. And the LS14, also a common C64 chip, I do have. The LS93, that's a counter, and I'm not sure if I have the LS version. I do have the version without LS at least. And also the 7407 without LS. I do think I have them. I'm not sure if I ever used them. And LS241s, I at least have 30 of those. A 16 MHz oscillator. I'm not sure if this is an oscillator or if it's a crystal. If it is a boxed oscillator, I probably do have them. If it's a crystal, I'm really not sure. Yeah, and this is just some jumper configuration stuff, and this is the alternatives for if you want to populate the power supply to power this one without using the normal 1541-2 power supply. Some optional pin headers. So I do think I'm good to go and have all of these in stock. I do have some VD1770 as I said, but I'm not sure if this is chip that I have replaced because they was bad or questionable, or if it is new chips. I have had them laying around for many years. So these I'm really not sure about. Yeah, and I forgot you have the memory chips, 62-256. I do have some of these, and D4364C. I probably have some of these too, and this is choosable, so you can choose either this or this. And since I do have this in abundance, I don't bother with checking this. So I do think it's just about digging in and finding the components, and I will be ready to start soldering up on this one. This time it is about this board, and this is an 1581 Replica Board, and this board have some changes from the original. You can either use the resistors here or the resistor networks here. They have added a power supply here, so that you can supply this with other voltages than the normal power supply. I have not seen any schematics for this, how this is wired together, but this board normally relies on both a 5 volt and a 12 volt power supply. But most 3.5 inch floppy drives just rely on the 5 volt, so I don't think the 12 volt really is necessary. And I have here all the components I need to solder this together. This is not the chips, but all the sockets that I need, and also pin headers and stuff. And I do have some issues with the power connector, as the power connector that is the standard for this drive does only have 4 pins connected, but my socket has some more pins, so I have to cut some of these. But what I will be doing today is that I will start with my resistors that I have done in my usual way and put them in the boom here to keep them sorted. And then I will continue with all the rest of the components, and it's not a huge list of things we need to assemble this, so the assembly process I do think will go very easy. I don't foresee any problems. And this replica board, it looks to be of okay quality. It's fabricated in PCB way and is on their order site that you can order these boards. The leads themselves on this board is very thin, and why they have done that I'm not sure, because it's more prone to failure of course if it's the thinner leads. Also you can get some other issues if the leads are too thin with power draw and so. But now I will just start to solder on the components and see how far I get in this part of the video. And we usually start with the lowest components, and the lowest components are almost always the resistors, so that's what we start with this time also. There are very few resistors in this construction, as most of them are in the 3 resistor arrays that should be mounted on this board. And as always, I check with the ohmmeter one of each of the resistor values to see if they have the correct markings. I have not stumbled upon one with the wrong markings yet, but never know with these cheap China parts. And this board has almost the opposite problem of what we had on the Ship Tester Pro, where there was too narrow a space between the pins on the layout of the resistors. Here they are almost too wide. And this time the 100 nanofarad capacitors fits exactly into the spacing between the holes, so they are very easy to fit. And there are some strange things about the layout of this board, because I don't think all the hole sizes are the same. On 1 or 2 resistors I saw that one hole was bigger than the other, and the pad was also a different size. So I don't know if there is inaccuracies in the layout of the board, or if it's PCBWay that has lowered the quality on this board. And now it's time for the IME filters, and in the boom they are described to be 270 picofarad. In the service manual they're described to be 100 picofarad. Why they have changed this, I don't know, but this is a decoupling device that decouples high frequency noise to ground, as you can see on the schematic symbols in the schematics that's in the corner of this picture now. Yeah, just checking that the ventilator that should suck out the smoke from the soldering iron is running as it should. Yeah, I'm just going to solder up these components, as the leads from these components are rather longer than the ones that we will have afterwards. So I just solder this up so I can cut the scrubs. Here on this resistor, it's R5, there is a slight problem because one of the pads is almost missing. It seems like it's just a via that is in place here, and this makes it almost impossible to solder. And by coincidence I have used here an older resistor that has thicker legs, so this could prove to be a problem. I have to measure out this afterwards before we test the board. Now it's time for the ferrite beads, and the ferrite beads I had is a bit on the big side, so I will have some difficulty with fitting them, but I do see that I get them through the holes, so I will be able to bend the legs so that they fit. And I have included a video here up in the corner to show you how a ferrite bead actually works, that it stops EMF noise to come through. And this animation is made by a company called Altium that deals in PCB making and stuff. And these ferrite beads are just a copper wire that's glued through a ferrite bead that's threaded over it. I was commenting on the quality of these PCB earlier, and here we can see that there is a bit of the solder mask that's actually come loose. And that's not something I've seen on PCBs from PCBWay before. And now I start out with the sockets, and I start with some of the big ones first. And I solder in just a few pins, so I will keep them straight to the board, and then I solder the rest afterwards. Yes, I have to admit it, here I made a mistake. And it's an easy one to make, and you have to be really careful with some PCB layouts. And as you can see of the embedded picture here, there is one IC that is turned 180 degrees in relation to all the others. So there is just one IC that has the pin 1 pointing towards left, and that is U4. All the others have the notch and pin 1 pointing to the right. So here I have to use the desoldering gun and do U4 all over again. Luckily, I have only soldered the 4 corner pins on U4, so it's very easy to take it out, turn it around and solder it back in again. Yes, luckily the soldering of the rest of the socket without any incident at all. And on the small sockets I used the ones with the round holes that will, some states that it gives a better contact to the ICs. And it's also much higher quality if you have to remove the ICs several times. I also placed the crystal oscillator in a socket, and this is a special socket. I have some of these from early 90s where the socket just are these small, it's just like a nail with a hole in, so you can think of this as a socket with the round holes without the plastic. So each individual pin is just punched through this metal holder, and when I solder it in, I just remove the holder afterwards. On these resistor networks I use a trick. I just solder one pin and then I just bend it in place afterwards, and then I can solder the rest of the pins afterwards. This 2-pole dip switch is a bit unusual. It has the handles to operate the switch turned 90 degrees, and that is so that this should be accessible from the back of the drive. And this switch will be used to set the device number for this drive on the IEC bus. On the pin headers I use my usual trick with just soldering one pin, and then I correct the directions of the pin so that they will stand in 90 degree to the PCB afterwards. And here I have a choice between an open header and a boxed header for the 34 pin floppy drive connector. And I choose the open one because it might be easier if I have some strange plug on the floppy cable. On this unhinged board there is a lot of these small pin headers, and a couple of them is only required if you use the power supply option, and also there are 2 headers that are meant to be coupling this together with another 1581 board if you do the 1581D setup where you have 2 drives connected with one cable. Normally when I do a build I put in all the optional connections and connectors too, but not this time, as I'm not going to set up this in a dual drive configuration anyway, so that won't be necessary, and they have no other use. And then it's time for the 2 DIN connectors for the IEC bus, and these are ones that I ordered originally for my C64 SixtyClone built some years ago. And I order up quite a large number of these because I also use them in Pi 1541 hats and other stuff where I need to connect the IEC bus. And since the hole in the PCB here are a bit large, you have to be careful with the alignment. And on the power switch I have to do the tweak that I talked about in the Commodore Resurrection video number 4, where I will cut away some of the metal on the bottom of the switch to make it fit closer to the PCB. And this is necessary to make the back end of the switch fit the case of a 1581 original case, if that will be in this board's future. And here you also have to be careful with the alignment, as this is going to fit through the back of the drive, and if it's mounted so it's at an angle, it's not certain that you will make this fit. And here I had to make one minor adjustment. Yes, and there I have all the major parts except the optional power supply placed, and then it's just the high-speed soldering process to finish up all the soldering that we have left unfinished when we placed the other components. And that was hopefully the last one I have forgotten, so a final inspection. Yeah, I think this is okay now. And now I have picked the components for the power supply, and this is actually a capacitor that's fit for a Commodore 64. And it's a bit big for this build, but I do think it will fit. The 4.7 microfarad capacitor is at least small enough. This is a China part, so I might have to measure up that one afterwards. And also I'm going to use this switch mode 7805 replacement. It will be overkill for this build, but it will run very cool, so there will be no heat at all, even if I supply this with 25 volts or something. The only major component left no soldering is the main power connector. Yeah, and at this point I have to admit that I actually made a mistake or an oversight, or at best a misunderstanding in my own head, because I mistook the DIN connector that was in the C64 power supply to actually be the same that was in the 1541-2 drive, and that's of course absolutely wrong. You can't connect one of these plugs into this one, and here you see why. You have the 45-degree angle between each in a normal DIN plug, and between these two pins you have a 72 degrees angle. That means you have only 36 between two of these pins. And it gets worse because, as you can see here, this plug is actually not on the straight line for a half circle as this is normally done. They are a bit further down towards the clip here. So there is no way you can force one of these without a hammer into one of these. So luckily I made the changes to the board that's suggested by the enhanced board, and actually placed the components for using an original power supply, and that is what we will be using when we populate this and we do the test. Because I have ordered these plugs, but they won't be here for a couple of weeks, so until then this is what we have to work with. So DIN plugs really are the best of standard. There is one for everyone. Yeah, and as we are going to use auxiliary power on this, I'm going to just solder up a quick adapter that we can use to connect this to an external power supply. And I just make this so I can connect this to my lab power supply. And I'm just going to reuse this cable that was left over from the build when I had the new LED in the C64G. And these are some cheap China copies of old design 4mm banana plug that I've used from time to time. And this one is a bit cost reduced, that it does not have screws. It's soldering, and the ones that you can buy from Distelec and so on, I've always seen them with fastening screws and not soldering. But that won't matter to us. We just solder them in place, and that will be good enough for our use here. And the rubber insulations on this will hide all our bad soldering, and even though if we have exposed some of the wire because we have used too much heat. So this is a plug that's easy to use in that regard. When we are waiting for this to cool down, we can attach the crystal. The crystal is supposed to only plug one way, but we do have to find out what's the ground pin on this. Yeah, when now the pins have cooled down, it's easy work to push the rubber insulation on top over the plugs. And this kind of plug is easy to reuse too, but you have to be careful when you try to pull the rubber off the plug. Yeah, and now it's just about attaching this to the right place on the board, and you have to set the jumper here to use the auxiliary power, and that's between 2 and 3 on jumper 2, as I'm shown in the embedded picture. Before I place any chips in this, I want to make sure that the voltage regulator is working properly. And this is the same supply as I used on the Retro Chip Tester Pro, so it should be about 7 volts input on these pins here now. And I will just take my fluke meter and try to measure this. And sorry about holding over my hand over the screen here, but this measured out to be minus 6.9 volt, and this is plus 6.9 volt when I put the measuring leads the right way. And then I will measure on the plug to the drive. There should be 5 volts. And we're not measuring anything here, but of course the power switch is off. So we turn on the power switch, and then this should be 5 volts, I hope. And it is. So that means that the capacitor and the voltage regulator is powered even though the switch is off, and that is not a very good design in my opinion. Yeah, but at least we have established that there are 5 volt present on this drive, and then we will be ready to populate this with chips in the next episode. Yes, and this is as far as we got in the first episode on our 1581 Resurrection, or as I've called it, about Bit Nibbling the 1581 onto another drive. And I think we have got up to a good start, even though we had the snag with the power connector. I've now made this lead to connect this to auxiliary power, and I've measured the power supply so that it gives out the right voltage. So next time it's about populating this board and starting to try out to see if anything works. With a bit of luck, we might get a working 1581 during the next episode. If not, there will have to be a part 3. So, thanks for watching. Hope you enjoyed the content. Please hit like and subscribe if you want to be notified when we post new videos. And please make a comment below if you have some comment, good or bad, about the video, the content, the presentation, whatever. See you in the next one. Thanks for watching.